Download this code from codegive.com, link in the description below. 206 Partial Content HTTP Status Code CSS Portal, a comprehensive tutorial. This tutorial will delve into the 206 partial content HTTP status code, explaining its purpose, usage scenarios, and how to implement a CSS portal that leverages it. We'll cover everything from the basics of HTTP status codes to practical code examples demonstrating range requests and dynamic content delivery. Understanding HTTP status codes and 206 partial content. What are HTTP status codes? HTTP status codes are 3-digit codes returned by a web server in response to a client's, example browser, request. They provide information about the status of the request, informing the client whether the request was successful, encountered an error, or requires further action. Categories of HTTP status codes. 1XX, informational provisional response, indicating the request was received and is being processed. 2XX, successful, indicates the request was successfully received, understood, and accepted. 3XX, redirection, indicates further action needs to be taken by the client to complete the request. 4XX, client error, indicates the client made an error in the request. 5XX, server error, indicates the server encountered an error while processing the request. 206 partial content, the focus of this tutorial. The 206 partial content status code is a specific HTTP status code within the 2XX, successful, category. It signifies that the server has successfully processed a partial request for the resource. This means the client only requested a specific portion of the resource, and the server has fulfilled that request. Key characteristics. Range request. The 206 status code is always associated with a range request header sent by the client. This header specifies the byte ranges of the resource that the client is interested in receiving. Content range header. The server must include the content range header in its 206 response. This header specifies the portion of the resource being sent, example bytes 1000-2000/5000, indicating bytes 1000 through 2000 out of a total resource size of 5000 bytes. Caching considerations. When serving partial content, servers should carefully manage caching to ensure consistency. The cache control and etag headers play crucial roles here. 2. Why use 206 partial content? Real-world scenarios. The 206 partial content status code is crucial for several web development scenarios, significantly improving user experience and server efficiency. 1. Resumable downloads. When downloading large files, videos, software, etc., connections can sometimes be interrupted. With 206, the client can request the remaining portion of the file by specifying the appropriate range header, resuming the download from where it left off instead of starting from the beginning. This is especially helpful for users with unreliable network connections. 2. Video streaming. Video streaming services heavily rely on 206 to deliver video segments efficiently. Clients can request specific chunks of the video as needed, allowing for adaptive streaming and optimal bandwidth utilization. 3. Progressive loading. For web pages with large content, you can initially load a smaller portion of the content, example the initial view, and then progressively load the rest using 206. This significantly improves the perceived loading speed of the page. 4. Seeking in media players. When a user seeks to a specific point in a video or audio file, the media player sends a range request to the server to retrieve the content around that point. 5. Large document access *. Similar to video streaming, you can efficiently access parts of a very large document without downloading the entire file. 3. Implementing a CSS portal with 206 partial content. Let's create a simplified CSS portal that dynamically loads sections of CSS code using 206 partial content. We'll focus on the server-side implementation, using Node.js for simplicity, and the client-side JavaScript for making the range requests. A server-side, Node.js. 1. Project setup *. 2. Server.js *. Explanation *. Dependencies * requires Express for the web server and FS for file system operations. File path * defines the path to the styles.css file. Root handler /styles.css. fs.stat gets the file size of styles.css. This is crucial for determining the total size for content range. *req headers.range * checks if the request includes a range header. *range parsing * if a range header exists, it extracts the start and end byte positions. *fs.create read stream * creates a readable stream for the specified range of bytes. This is the heart of the 206 implementation. Response headers, crucial for 206. Content range, specifies the range of bytes being sent in the response. Accept ranges, indicates that the server accepts range requests. Content length, the size of the chunk being sent. Content type, text/CSS for a CSS file. *res.write head, 206, head, sets the HTTP status code to 206 and sends the headers. *file.pipe, res, pipes the content of the read stream, the requested byte range, to the response. No range header handling if no range header is present, it serves the entire file with a 200 OK status. Server start starts the Express server on port 3000. 3. Styles.css create a styles.css file with some content. This will be the CSS file we will partially load. B. Client-side, HTML and JavaScript. 1. Index.html *. Explanation *. Dynamic CSS style tag *. This empty style tag will be populated with CSS code dynamically. Buttons buttons to trigger loading specific sections of the CSS file. Load CSS section, function fetch, makes an HTTP request to /styles.css with the range header. Headers, range. Sets the range header to request a specific byte range. Response.status == 206 checks if the server returned a 206 partial content status. Response.text reads the CSS content from the response body. CSS element.text content plus =CSS text, appends the loaded CSS to the dynamic CSS style tag. This is the key to progressively adding styles. The plus equals is important to append styles rather than replace them. Error handling includes try, catch for error handling. The else if, response.status == 200, part handles the case where the server doesn't support range requests, it sends the entire file. See running the example *. 1. Start the server *. 2. Open in browser *. Open index.html in your web browser, usually http://localhost 3000. D. Testing and observing the behavior asterisk. Click the buttons Load Basic Styling, Load Header Styling, and Load Main Content Styling in sequence. Observe that the styles are applied incrementally as you load each section. Network tab in DevTools. Open your browser's developer tools, usually F12, and go to the Network tab. You'll see the requests to /styles.css with the range headers and the 206 status codes. This confirms that partial content is being served. Pay attention to the content range header in the response. 4. Key considerations and best practices. Determining byte ranges. In a real-world application, you'll need a reliable way to determine the start and end byte positions of specific content sections within your files. This can involve scripting, example using Node.js or Python, to parse the files and generate a lookup table or index. Consider using comments or delimiters in your files to make this process easier. Caching. Cache control headers are essential. Use cache control headers effectively to control how browsers and proxies cache the partial content. Consider using etag headers to ensure that clients are using the correct version of the resource. Etag and if range. The etag header provides a unique identifier for a specific version of a resource. The if range header can be used in conjunction with range. The client sends the etag value it has. If the server's etag matches, the server sends the requested range. If not, it sends the entire resource, 200 OK. This helps prevent issues caused by changes to the resource after the client has cached a portion of it. Error handling. Implement robust error handling on both the client and server sides. Handle cases where the server doesn't support range requests, the requested range is invalid, or there are file system errors. Security. Be mindful of potential security risks. Validate user input to prevent malicious clients from requesting invalid ranges or attempting to access sensitive data. Content negotiation. The accept ranges header should be used in the initial response, example when serving the entire file, to inform the client that the server supports range requests. Dynamic content. If your content is dynamically generated, you'll need to calculate the byte ranges on the fly. This may require more complex server-side logic. Advanced concepts and techniques. Byte range sets. The range header can specify multiple byte ranges in a single request, example range, bytes equals 0-99, 200-299. The server responds with a multi-part /byte ranges response containing each requested range. Implementing resumable uploads. The range header, combined with the put method, can be used to implement resumable uploads. The client uploads the file in chunks, and the server can verify the received ranges. Integration with streaming media servers. Dedicated media servers, example Wowza, Nginx RTMP module, are optimized for handling streaming video and audio. They provide advanced features like adaptive bitrate streaming and content protection. 6. Complete code example with etag and if range, improved caching. Server-side, server.js, modified. Changes. Crypto module. Added for generating MD5 hash etag values. Generate etag, function. Reads the CSS file and generates an MD5 hash to be used as the etag. res.setEditor, etag, sets the etag header in the response. req headers if range. Checks for the if range header in the request. Asterisk if range handling. Asterisk if range is present and doesn't match the current E-tag, the server sends the entire file, 200 OK, instead of a partial response. Asterisk cache control, public, max age equals 3600. Asterisk added to the head object for both 206 and 200 responses. Adjust the max age value based on how frequently the CSS file changes. Client side, index.html, modified. Changes asterisk. Asterisk current tag variable asterisk stores the E-tag received from the server. Asterisk if range header asterisk adds the if range header to the fetch request if a current tag exists. Asterisk E-tag update asterisk updates the current tag with the E-tag received from the server in the response headers, both for 206 and 200 responses. How the E-tag / if range improvement works asterisk. 1. The first time you load a section, the client doesn't have an E-tag. The server sends a 206 response with the requested content range and an E-tag. 2. The client stores the E-tag. 3. On subsequent requests for other sections, the client sends the if range header with the stored E-tag. 4. If the styles.css file hasn't changed on the server, the E-tag is the same, the server sends the requested range with a 206 status. 5. If the styles.css file has changed, the E-tag is different, the server ignores the range header and sends the entire file with a 200 OK status and the new E-tag. The client updates its current tag with the new value. This ensures that the client always has a consistent view of the CSS file, even if it's updated on the server, while still taking advantage of partial content delivery when possible. 7. Important considerations for production environments asterisk. Content delivery networks, CDNs. When serving large files, especially media, using a CDN is highly recommended. CDNs can cache content closer to the users, improving download speeds and reducing the load on your origin server. Make sure the CDN supports and is configured to handle range requests and correctly cache partial responses. *HTTP/2 and HTTP/3 These newer HTTP protocols have built-in features that can optimize the delivery of content in chunks, potentially making range requests more efficient. Monitoring and logging implement monitoring and logging to track the usage of 206 partial content and identify any issues. Monitor metrics such as the number of range requests, the size of the requested ranges, and error rates. This tutorial provides a solid foundation for understanding and implementing 206 partial content. Remember to adapt the techniques and code examples to your specific needs and always consider caching, security, and performance optimization in your web applications. Remember to adjust byte ranges to match your specific CSS file content.